Hello and welcome to the ninth video in Darton College's Science Department's Flip Learning series from P3 Forces of Motion. So the aim of this video is that by the end of it you should be able to describe the factors that affect the kinetic energy, how much kinetic energy an object has. You should be able to use and apply the equation for kinetic energy, relating the numbers that you get for kinetic energy to braking distance, and also to rearrange the kinetic energy equation to work out the speed or the mass of an object. Right, firstly, basic principles. If you have two cars and those two cars have the same mass and one of them is travelling faster than the other, then the one that is travelling faster will have a higher kinetic energy. Also, if you have two vehicles that are travelling at the same speed, one of them has a much larger mass than the other, then the one that has a larger mass will have a higher kinetic energy. From this, that we can infer that the two things that affect the kinetic energy of an object are mass and speed, or more technically, velocity. The only other thing to add is that means that if there is no movement, if an object isn't moving at all, that means its kinetic energy must therefore be zero. This equation is probably the trickiest one that we'll come across because it involves squares and it involves a multiplication by a half. So the actual equation is written that Ke is equal to a half m mass v velocity squared. So you square the square of the velocity times by the mass times by a half gives you the kinetic energy of an object. Not forgetting that you need to convert all of the units into the appropriate SI units of joules, kilograms and meters per second. Right, here's one to try. I would always do the velocity squared first. So the first thing to do is to find the speed, which is 20, and multiply it by itself to find out the speed squared, which is 400. Multiplying that 400 by the mass of 1200 gives you 480,000, and times that number by a half, which is the same as dividing it by 2, and that gives you an answer, kinetic energy of 240,000, and the unit is joules because joules for energy. Here is the second key principle about kinetic energy. As well as needing to know that mass and velocity affect the kinetic energy of an object, you need to know that the effect of mass changing has a linear relationship with kinetic energy, which roughly means that if you double the mass, you double kinetic energy. However, because in velocity we have velocity squared, then what we end up with, if you double speed, you increase kinetic energy by a factor of 4. If you treble speed, you increase kinetic energy by a factor of 9. So whatever you increase the speed by, you increase the kinetic energy by the square of that number. So how do we link that to braking distance? Well, we saw in an earlier lesson that the faster that you're going, the much greater the distance it takes to stop. And that's because of the amount of energy that a car has. So a car travelling at 30 miles an hour has a braking distance of 14, whereas at double the speed, the braking distance has increased it by more than 3 times. This is because of that principle that I highlighted in the last slide. If the speed doubles, the kinetic energy goes up by a factor of 4. So the brakes have to work 4 times as hard to transfer the same amount of energy away as heat and as friction. Here's a couple more examples that you might want to try. You can pause these before we go through. As I said, I would always do the speed squared first. So 10 times 10 gives you the velocity squared of 100. Multiply that by the mass of 6,000, which gives you 600,000, times that by a half, which gives you kinetic energy of 300,000 joules for this elephant with a mass of 6,000 kilograms charging at 10 meters per second. Here's another example. Same elephant, except this time it's only moving at 5 meters per second. So we do 5 squared, which gives us 25. Multiply that by the mass and times it by half to give us a kinetic energy for the elephant of 75,000 joules. You'll notice that that's 4 times less than the elephant in the previous screen, and it's travelling at half the speed, as I said before. The cannonball, which is travelling at 125 meters per second, so 125 times 125 is 15,625 times by the mass of the cannonball, which is 200, times by a half, which gives you a huge kinetic energy of 1,562,500 joules. And that's principally because the cannonball is going so much faster than the elephant. This is the rearrange version of the equation that you need in this one. The rearrange version of the equation ends up with being a square root. You need the square root of 2 times the kinetic energy divided by mass. That gives velocity as the subject. So in this equation, where you have kinetic energy of 75 and a mass of 0.06, you need to do 2 times 75, giving you 150, before you divide that by 0.06. So 150 divided by 0.06 gives you 2,500. You then square that number. Sorry, I should have said square root that number. So the square root of 2,500 is 50. So that ball is travelling at 50 meters per second. So in summary, the mass of an object and its velocity affect that object's kinetic energy, with velocity having the greater effect. The equation is Ke is equal to half mv squared. Faster cars have more kinetic energy, so take longer to stop. A doubling of speed quadruples braking distance. And the rearranged equation is square root of 2Ke over mass is equal to velocity. Thank you very much for watching. Don't forget to bring your evidence to lesson. This lesson takes place on Thursday, the 8th of May.